Hi everybody, this is Shujaat Mubarik, and today I am going to demonstrate you that how we can perform the independent samples t-test, and I'm also going to interpret the results of the independent samples t-test. So first of all, before going for the test, I'll just explain in a one line that what is independent samples t-test. It is basically used for comparing the mean scores of the two different groups. Are we if we want to see that whether the two different groups are same or not, so we apply the independent samples t-test. Here is the test summary on which we are going to perform the independent samples t-test. Basically, we want to check that whether there is a difference between the mean self-esteem scores of the males and females. Means we want to check that whether the males and females differ in terms of their self-esteem or not. What we need or what we require is first of all we need one categorical variable, which is sex, means males and females, and the second variable, that is a continuous variable, our dependent variable, which is total self-esteem. So what this test would be doing, this test will divide the dependent variables into two groups, males and females, and then we'll compare the means of the two groups with each other in order to see that whether any statistical difference exists or not. So let's go to the SPSS in order to perform this test. I have obtained the data set for this test from the Julie Pallet's website, survival manual, SPSS survival manual, in order to perform this test. So that's why the results and everything would be almost be identical to that you could find also on the website. So we just go on analyze, uh, compare means, independent samples t-test. Since I have already performed the test, so you could see the variables are here, but anyway, in this test variables box we have to put our dependent variable, which is total self-esteem. So I just quickly move total self-esteem score here. In the grouping variable we have to put our categorical or dependent variable, which is sex, and we would define move here. In this define groups label, basically we have to give the name or nomenclature to our group. So for group 1, which is male, we have put here 1, and group 2, which is female, we have put 2. So means that 1 for male and 2 for the females, and then we click continue, and then it's okay. So here comes our results. These are our results. You could see I have just brought these results in on the here on the PowerPoints in a formatted way, which are already obtained from the Julie Pallet's website. The results can these results output can be interpreted in 4 steps. Step number 1, we explain the descriptive statistics in order to see whether there's a balance between the groups, or there's a highly imbalanced group or not. So you can see that here in our case 184 males and 252 females, so almost it's a kind of a balanced group, not highly balanced, but you can see that not very highly imbalanced group. Then we go toward the equality. We want to check that whether the equality of the variance is assumed or not. For that we have to see the results of the Levene's test for equality of variances, and this left hand box would be used. This particular box is used in order to see the Levene's test for the equality of the variance. So basically if the significant value of Levene's test of equality of variance, if this value is less than 0.05 or equal to 0.05, we assume that we reject the null hypothesis of equal variances assumed, and the result is that equal variances are not assumed. So if it's the case, so the below row of the information is used for the further analysis. If the value of the Levene's test is greater than 0.05, so which is that we fail to reject the null hypothesis, means equal variances are assumed, so this row of information is used for the further analysis for the hypothesis testing. In our case, the value is greater than 0.05, it means that equivalent variances are assumed. So we further go to the right hand box and on the upper row, and use this information for the hypothesis testing. So for hypothesis testing, are whether to see that whether there is a significant difference between the males and females total self-esteem. We have to see this value of sig, which is significant value. It should be less than or equal to 0.05 in order to reject the null hypothesis for no difference. But here in our case the value is greater than 0.105. It means that we are failed to reject null hypothesis, means there is no difference between the total self-esteem of male and female. Yes, in the this is the step number 3. Step number 4, even we can just check that if there is any difference, what is the magnitude of the difference. In our case, although there is no statistical difference, yet we can check the magnitude of the difference between male and female. The formula for checking that is eta squared formula. This is the formula given. You could see with the help of this formula we have calculated the values of eta squared, which are 0.006, and this is the scale given by Cohen 1988. If we put this value on this scale, so we could see that the magnitude of the difference is very low. It's 0.006. Basically it's a 0.06% or 0.6%, which is very small, and that's why it's not statistically significant. This is the way how we can interpret these results. Once you're writing the paper or once you're writing your research report, it can be expanded, but this can be a kind of a format in which you can write your results. An independent sample t-test was conducted to compare the self-esteem scores for males and females. There was no significant difference in the scores for males, and here in the bracket we have written the mean values and the standard deviation of the males and then females, and we have put written here the mean value and standard deviations, and then we have put here the t value, and in the bracket you could see the total number of samples, and then it's a t value and p value, in order to not bother the reader to go to the tables, and then you can just see the informations here. And then the magnitude of the differences in the means was very small, which is eta squared 0.006. So this is the way we can test. We can go for the independent sample t-test, and we can interpret the results. This is again a summary or the procedure of independent sample t-test to perform on the SPSS. Thank you very much.